Good evening. This is Steve Wilson from the Illinois State Water Survey, and tonight we are having a webinar on protecting well water from contamination. This is the second webinar we've hosted for this new round of funding through US EPA. Jennifer Wilson is with me from the Illinois Water Resources Center. We're both at the University of Illinois, and I wanted to mention that the class and the webinars are sponsored and funded through the Rural Community Assistance Partnership and US EPA. If anyone can't hear or can't see what they're supposed to be seeing, please type a message in the message box on the GoToWebinar taskbar that says my system's running slow, and I'm not sure what's going on there, so but we will move forward. Okay, so today we're talking about really about proper construction and siting wells, understanding where your water comes from so you understand how it gets in your well, and based on your surroundings what your risks are. And then it goes without saying to treat your water system. It's an expensive, valuable asset. Knowing how to maintain it, understanding how it works is critical to its longevity and also saving you money in the long run from needing another well. Quickly, I want to go through water moving through the ground. This is an example of sand grains in a sand and gravel aquifer. So this sand exists under the ground. It's about 30% pore space, which is the air between the grains itself, which you see here, and it shows the arrows with the blue lines. That's where the water sits and moves. And because it's a porous system, it's if you had a jar of sand in your hand, a mason jar full of sand, it would be about 30% air. And underground, that's where the water in the sand and gravel aquifer sits. And so it's this sand, or if it's a bedrock aquifer, which I'll explain in a second, is what makes an aquifer an aquifer. It has water that's available to a well, and it moves through all the grains and the geologic materials to get to your well because of differences in pressure and flow. So there's different kinds of material. I mentioned sand. Sand doesn't look like beach sand you see, when you go swimming. That's well sorted sand that shows in the middle there at the top. Most of the time it's poorly sorted, and it has gravel pieces and different size grains, and depending on how those all fit together make a difference on how much water is actually available. Once you're below, or if you're in an area where there aren't sand and gravel aquifers, which are in glaciated areas and along river valleys, you may have bedrock, which is either granite or limestone, some kind of fractured rock, sandstone. And in those cases, a lot of the water that's available is in fractures or caverns that have developed because of water movement, as well as sandstone. There's also some water actually in the matrix of the cemented sand that makes up sandstone. So it really depends on where you're at, what kind of porosity and how much water might be available. For instance, in granite, you may only have 1 to 2% of water available based on the borehole you drill, versus a limestone, you hit a cavern, a cave, and you may have more water than you could possibly need. So this figure just shows the different types of aquifers have different permeability, meaning it's the ease of how water flows through those. So larger grains like gravels, water can move much faster through than they can a silt or a clay. There may be as much water in a clay as there is in a gravel aquifer, and clay isn't an aquifer, but because all the grains are so small, the clay particles are so small, it takes forever for the water to get through those, and that's why clay is not considered an aquifer. And the same way with rock, it depends on the type of material. Shale, for instance, is basically cemented clay, and it's basically considered impermeable, and it's aquitard is another term which means it retards water flow instead of allows it to flow. And if you run into shale, I'll show an example of a well log in a little bit that has a mistake in it and has this shale listed as the aquifer, and it's not. So here's an example of water movement. These are, if you want to look at these as bowls of material, if you pour water in at the top, water flows through the sand and gravel, it's going through all the grains, and it kind of moves at a pace down through the aquifer. If you're in dolomite, it's moving between the actual pieces of rock and those materials. Then if you're in crystalline bedrock, which is on the lower left, which would be like granite, you have very little water available. You have to hit a fracture when you're drilling, and a lot of times, as I said, you have very little water available, a lot of low-yielding wells, but in some places that's the only option you have. And bedrock isn't, one, it's not level, and two, it's not consistent as far as the type of material. The example in the lower right shows sandstone and dolomite. You might have intermixed shales or other types of materials that retard flow and keep the water in certain units. And so you may have a sandstone at 1,000 feet that has water in it, and there may be a shale above that that doesn't have anything. One of the other issues that's important for wherever your well is sited is the surface soil. So if you're in a sandy area, which would be the more vulnerable situation on the right, whenever something gets spilled, it infiltrates right into the ground. If you're in a more clayey area with good dark soil, then the infiltration may be slower if it's more clayey and silty, and there may be more runoff of material, and it may be very slow to infiltrate. So there's really two pieces to contaminants getting, one into your well and two into the ground. It depends on the permeability of the soil and the ability of that contaminant to move down through the soil zone into an aquifer. And it also depends on how permeable the aquifer is and how deep the aquifer is. The general rule is deeper is better, because in this case, sand acts as a filter and it binds a lot of these contaminants. And so even if it's sand at the surface, if your well screen or where the well intake is 100 feet below land surface, it may be sufficiently protected. So here's an example of a home where, if you can see this on the upper left, there's a little bulldozer there, and he's burying barrels. He thinks his well is safe because he's moved so far away from his home and his well, but an aquifer exists over large areas in a lot of cases, and it has a flow direction. So if it turns out that you're up gradient and the flow direction in this case is from left to right, it's towards the home from the dump, then eventually, even if that unsaturated zone in the material where the dump is isn't very permeable, eventually that material is going to seep down and get into the aquifer and make its way towards your well. And that's why knowing the history of the area around where your well is, what other sources there might be, livestock, septic, businesses, anything that might, storage of pesticides, all of those things are important to understand when deciding where to put your well or what even you might want to test for. So for instance, if there's a livestock facility near you, you might want to test then for things that you might see if that's a concern. And knowing the flow direction a lot of times of an aquifer is a very hard thing to determine. Usually State Geological Survey or U.S. Geological Survey in your state or Department of Natural Resources are probably the most likely to have some idea, or the driller in the area, the local driller who's drilled a lot of wells will probably have some idea of the flow direction of if it's a substantial aquifer that many homes are on. And so the best advice we give folks all the time is to always contact local sources of information and find out as much as you can about your well and about the surroundings in your aquifer. That's the best way to know what's going on. This is from the Minnesota Department of Health, and it's a sheet. Here's the top half, and I'll show you the bottom half next. But these are the Minnesota rules for isolating your well if you're going to drill a new well. And there's there's a lot of things here, but everyone has a reason. And these minimum distances are just that. In many cases, I'd recommend going much further if you can. In some cases, you don't have a chance. You're in a subdivision, and houses are within tens of feet of each other. You obviously can't do a whole lot. If everyone's on a septic system, you're going to be near somebody's septic system. So the key is understanding groundwater flow and direction, and to make sure your well is up gradient of where the septic may be, so that the septic discharge and the leach field are going away from your well instead of towards it. So, but here's, a lot of things that you might not consider, and this particular document is available on privatewellclass.org's website under the resources page. I'm not sure which lesson it's under, but you can look under the resources and see a lot of these materials. And again, here's the bottom half. Certain things, and here's a drain field at the bottom, and if you have agricultural chemicals, just to make it harder for those materials, if there's a spill or a leak, to actually cause a problem for your well. And again, if you are in a rural area and you store pesticides or even garden chemicals, your best bet is to make sure you store those away from your well, and if you know the flow direction, to make sure that you're storing things down gradient from your well, which means so that the flow in the aquifer is from your well towards where you're storing things, not from where you're storing things towards your well. And a local health department or even a co-op extension office or your state geological survey can probably give you help. In Illinois, we have a state water survey, obviously where I work. We're the only water survey in the country, but that's our job here in Illinois, is to help well owners determine some of those things, how deep they should drill and all those issues. So well type matters, and there's really three types of wells: dug and bored well, and those are generally either where there's really no aquifer, or it's a very old well that was hand dug because that was the available technology at the time. Otherwise, they're either drilled or driven in the sand and gravel aquifer, which means they have a well screen, or they're drilled into consolidated bedrock, which is the sandstone and dolomite and limestone that many folks have, or granite around the country. And the differences I'm going to go through, in some cases you may have choices. I know here in Illinois it's glaciated, so we're fortunate enough that in some areas you can drill a well at the same location and hit 3 or 4 different aquifers, but in many cases you may not have any, which means you might be putting in a dug or bored well, which store water and from shallow infiltration, and that's why they're more risky. If you don't have your well log, you should try to find it in your state geological survey or Department of Natural Resources, or it depends on the state. In Washington State, it's the Department of Ecology. Different states have different agencies that maintain those well records or are in charge of regulating well construction. But find it. You can look, type your state name and water well log in Google, and you should be able to come up with the agency that has that information and help you find it. If you know your driller, they should have a copy of the log if you don't have it, and you can go to them and ask them for a copy. So dug or bored wells, these are the most risky in most cases. They're large diameter because they're meant to store water. Water doesn't flow into these wells very readily. They're meant to get slow seepage. So it's usually concrete tile, and water seeps in from the water table, or in some cases thin sand lenses. A lot of times they're 3-foot diameter and they're less than 40 or 50 feet deep. So that anything on the surface that gets in a well or infiltrates into the ground can seep into these type of wells. I just had a well owner today from New Hampshire contact me. They have E. coli or coliform in their well. They're not sure why, but it's an old dug well, and it turns out their leach field is plugged, and so they found a patch where the seepage is actually coming up out of the ground behind their house, but that shallow infiltration is allowing the water to come back towards their well when they use it, and it's causing contamination of their well. So in most cases, a large diameter well is not the best option if you have other options. These are just some examples. It may look, the one in the lower left here looks like a normal drilled well. A lot of times they're concrete slabs like on the right. In some cases they're very old. This is an old hand dug well that's covered with boards and tin. And spiders, frogs, all kinds of things can get in these wells, and they're just at risk for contamination. Here's 2 examples of properly constructed wells that are bored wells, and you can see it shows on the diagram on the left, it's 36-inch diameter, and these are sections of concrete tile, so the water seeps in at each of those joints. They're set on top of each other. They're not actually cemented together, and that way water can seep in. And if this is properly constructed, it's got concrete up in the upper 10 or 20 feet, 10-foot minimum it says. In some cases they put them in like they have here on the right, where the upper 10 feet or so has actually been filled, and there's a concrete pad at 10 feet and the well starts below that. And that's meant to protect the well, at least to some degree, from anything at the surface. It's got to go through 10 feet of material before it can actually get in the well. So sand and gravel wells, these are finished in sand and gravel, and so in order to keep the sand out of the well, they use a screen. This is a picture of a well screen, and it's woven wire basically that has small slots, so it's sized based on that the size of the sand grains. Whenever the driller drills the well, he sees the size of the grains and determines what size slot screen he needs to use, and it goes in at the bottom of the well. So the water seeps in just at that point. A lot of times these are 5 foot or less, and so it's only the bottom 5 feet of your well that's actually providing water. But because sand's so permeable, usually it provides plenty, and that's why you don't need to have the whole length of your pipe screened. Here's an example of a well log from Illinois, and it's only a 45-foot well, but the screen, if you look at number 14 and number 12, it says the water's from sand and gravel from 41 to 45 feet below land surface. And the first 41 feet is galvanized pipe. It shows that in number 15, and then the last 4 feet is that screen. And so that's where the water's coming from. In this particular example, there's 4 feet of soil and then 41 feet of sand. So it's sand from the surface basically, and so the deeper they can go, the better off they are. Yeah. Here's a diagram of a typical sand and gravel well. The screen, it shows at the bottom, the blue is the sand, and most of the time these are submersible pumps because they're more than 20 or 30 feet deep. They're sometimes much more, and so it's pumping water. This actually is a bad example. It's the diagram I had, but most of the time you don't put your pump in the well screen because of the velocity issue and causes sand to seep through. But this is just showing what that looks like underground. And this is a bedrock well. So the difference in a bedrock well versus a sand and gravel well is that once you reach bedrock, you don't continue the casing in a lot of cases. I'm not sure you can see this real clearly, but you can see where it says steel casing on the diagram, and then on the opposite side it says 10 to 20 feet of casing into bedrock. And then the casing stops. So from that point on where the casing stops, that's an open hole drilled in bedrock. And the idea here is the bedrock, like the diagram I showed earlier of the bedrock fractures, you're hoping to hit fractures in the solid rock, so that's where the water exists and it can seep through. And so in some cases you may have a large fracture that runs for several miles, and you see a line of wells that are actually very good and provide a lot of water that are able to tap into that fracture, where if you're off of that, you may not have any water or a very low yielding well. So it can be influence over large distances, and that's the risk of these types of wells. If there's some kind of contamination several miles away, that one fracture may be the only water source for a number of wells, and so water flows through that fracture. It's an open crevice much more freely and can move a large distance. And here's an example of a geologic log for a bedrock well. If you look at on the bottom right where it shows the different formations, there's brown clay for 4 feet and then some sand and gravel. Some folks may have stopped and tried to put a well into that sand and gravel, but it might have been dry. When you get down to the broken limestone at 189 feet, then there's 68 feet of limestone. The casing record, number 15 above that, shows that there's 199 feet of casing. So they went 10 feet into the bedrock and then the casing stopped and it's open hole from that point on. So it's that open section of bedrock from 199 to 260 where the water's seeping in the well. And the static level is only 130, so water's coming up in the well up to 130 feet. So, but understanding your log is critical to knowing, a well that's steel casing to 199 feet means that surface influences are much less of an issue. You've got 200 feet of material between where the water's getting in your well and any surface contamination that you might find. So that's generally much more protected, and you see less influences, like you're less likely to see higher nitrates or things that are surface related. So some other things to consider: well depth. Deeper is generally better. I left a word out here, sorry about that. The deeper you are as far as where your water is coming from, the less risk you have of a surface contamination. Now, it doesn't mean if you have a 500-foot well that it's completely safe. It may be that there's only 50 feet of casing. You just have 500 feet of open hole or whatever in a bedrock because you needed that for water. It matters where the water is actually being taken from, what depth, and that's where your well screen, if you're in sand and gravel, comes into play, and those things. Location on the landscape. You obviously want to have your well in a higher location, not a lower one where there's a chance for during heavy rain, that ponding, any of those things that might cause anything around the casing, water to seep or that sort of thing. If you can find out the flow direction of the groundwater that your well is tapping into the aquifer, that's very important, especially for determining where you should put your well. If you have a choice, you want to put your well up gradient so that the water's flowing away from your well towards the rest of your property, where you might have some kind of influence or something that could get spilled, or a gasoline leak, or a tank would overfill, or any other issue. So in the area surrounding your well, you want it to be open so you can access it, and if you do need to do repairs or you need to fix anything, again, it should be in a higher area if possible, and it should be free of any kind of anything in the area. And I guess by area surrounding your well, we're also talking about if there's a neighbor has livestock, or if you know where your neighbor's septic and your septic are there any old businesses in the area or anything else that might have influenced, that could have caused some kind of contamination on the ground. And knowing those things might help you diagnose if there's ever a problem. So poor well construction. So especially in the last, say 20, 30 years, well construction codes in most states have become much more stringent to help protect not only your well, but also the source, the aquifer. A lot of old wells, if you dump something in your well, you may have contaminated all the wells in your area for, within a half a mile. And so to help protect both your well and your neighbors, well construction codes have changed such that they're more properly constructed and there's less risk of a surface contamination. But most old wells that were in pits were grandfathered in, and so we still find a lot of wells that are in pits today, and those are dangerous for a number of reasons. One, so the story there is now there's a thing called pitless adapters, and they allow you to run water into your house underground below the frost line if you're in the northern part of the country, and that eliminates the need for a pit. Many times pits were dug and a well was put in a pit because you wanted to keep the top from freezing and your line from freezing. And so nowadays there's really no reason to do that. And the bottom line is if your well is in a pit, you should hire a contractor, a well contractor, a driller to come out and bring it up to code, because it's likely not meeting code. You legally probably don't have to do anything there, but it's a good idea. And also, especially in rural areas, there are many hand-dug wells that are still in use just because they've been there so long and they still work. So these wells, again, are using the water they receive is generally infiltration from near the surface, and it's the kind of well I grew up on. They're not safe in many cases, and it's better if you can use a different kind of well if you have that situation. And if you do have an old hand-dug well, you should probably test it more often. We recommend once a year for coliform nitrate, and there's a whole suite of things you should test if you've never tested at all. But once, if you're using an old dug well, we just had this person from New Hampshire. Their water chemistry was such that it didn't make sense. It had low pH, and several other constituents weren't normal, quote, normal for groundwater. Well, then she shared that there had been a large rain the night before, and because it's such a shallow well and it's a dug well, it was basically rainwater that they were sampling. And so that's how quickly things can get into those wells in certain situations. So yeah, they provide an opportunity for surface contamination, and they're also a safety hazard. You see cases all the time where an old buried well is just got a wood plank over it or some sort of thing, and either they've driven a tractor over it and it's caved in, or someone's fell in, and those sorts of things. So they're just not good to have around. And here's a couple examples. And this one on the left side here, this is actually from Washington State Department of Ecology's blog, and a woman died. The part of the plywood she had there gave way, and she fell in, and it killed her. So it's not a good idea. So bring them up to code, extend the pipe up to the surface. This is where you need a licensed contractor, install a pitless adapter, and have someone who's an expert come out and take a look and determine what you need to do in order to make it safe, and also protect your health as the best way possible. Septic systems. If you have a private well, you likely have a septic system, and that's not true in every case, but it's generally the way it is, and it needs to be managed just like your water system is. If you don't take care of it, you don't pump it on a regular schedule, and you don't manage it properly, it will fail and either back up into your house or cause contamination either in your yard or in your aquifer or in your well itself, because there's a natural process that a septic system is supposed to provide to help use biological treatment to get rid of all your waste, and when that system isn't working properly, they can be a problem. And a lot of cases, in the old days, if you will, you hooked your septic, instead of having a drain field, you ran into a field tile, into a field, or straight to a tile that runs into a stream. Both of those are illegal, and they also don't allow, you're causing contamination. And if you're not sure, call a septic contractor and have them come out and check it out. If you haven't had your septic pumped in, say, 3 or 4 years, it's very likely that it's on its way out, or it isn't working properly. They need to be pumped on a regular schedule. Here's just some examples of how this works if you're not familiar with it. On the left here, an inlet pipe. It comes from your house. This tank allows the solids to settle out, and then the clear water can go out the outlet pipe. That runs into, if you look at the left diagram, some kind of septic field or drain field where it can slowly migrate through the soil, and like I said, biological treatment, because it's so high in nutrients, basically that's how it gets rid of its, it cleans itself up. So, and then on the left, the 21-inch access pipe is for pumping out the sludge every so often. If you don't, the sludge will build up, eventually clog your outlet pipe. All the sludge will start going out into your drain field, and that's when all the problems start to occur. I wanted to point out that US EPA has developed this new program called Septic Smart, and there's a lot of really good information if you're not familiar with your septic system or how it works. If you look there where I did a screenshot here where it says home, and then it's the basics, why maintain, proper care, and resources. There's a lot of good resources. There's a toolkit if you're someone who works with well owners, and the best way to find this is if you Google Septic Smart as one word. This is the first thing that shows up on the search. But it's really, there's a document here, it's about 10 pages that you can download, a PDF, that really walks you through from very basic to all the proper care and things that you need to consider depending on your situation. It's different all over the country depending on whether you're in an area that's glaciated, how much surface soil you have before rock. There's just so many differences in geology that you really need to understand your area and talk to your local health department and those folks to have a good understanding of what's best for your septic system. And I'll mention that one more time. Your best bet is always to become familiar with your local sources of information, your local health department, your co-op extension person, your state department of health, and your state geological and survey, for instance. because they can provide a lot of useful information about geology and well logs and water flow and all those things. So, abandoned wells. Abandoned wells are everywhere. We estimate in Illinois, the State Water Survey has about 500,000 well logs of wells that we know of that are documented, and there's probably 2 million wells that are actually in Illinois, and the rest of those are undocumented, and many are not being used and not properly sealed. So they're, like well pits, they're really a safety hazard. Not only can you fall in them and those sorts of things, but they're also a source of contamination. An open well, if someone pours, they think, well, it's a good place to pour something down or whatever, it might be a conduit directly to the aquifer, and it could contaminate. There's cases where it's contaminated an aquifer, and many people in their wells have had to just go off of that aquifer and can't use it anymore. So if you know you have an abandoned well in your property, you should abandon it properly, and that's sealing it and filling it with clay and bentonite, and it's a responsibility everyone has. If someone were to walk on your property, even if they were trespassing, and fall into that and get hurt, you could be sued. So it's just really not worth the risk. It's better to take care of it. And this is the 2 pictures on the left are also from the Washington Department of Ecology's blog. This is from last year. One shows a horse that fell in an old well, and the other shows fire and rescue pulling a man who fell in 45 feet. He actually survived. These pictures of these newspaper clippings on the left are all from Illinois from back in the 90s. Everyone remembers Jessica McClure, that's old enough. Made national headlines when she was trapped in a well for 18 hours. It was on CNN Live. I remember watching that back when that happened. But the other 3 of these are all from Illinois, where folks died from falling in a well. So it does happen. It happens more than you think. You just don't put it all together. How many people have died from falling in a well? I have no idea, but they are out there, and they're a risk. Just even taking a hike in the woods, if it's an area that may have had homesteads on it at some point, you're taking a risk of falling in a well. So that's really what I have. I wanted to bring up, I'm assuming everyone on the webinar is taking the class or has taken the class, but if not, if you go to privatewellclass.org, this page, or this actually might be an older screenshot, but this is the home page for the class. You can sign up there, 10 lessons delivered through your email. There's a email us at info@privatewellclass.org if you have questions. There's actually also a phone number listed there now that we've put up. If folks have questions, they can call us, and we'll try to help them with their issues. I guess what I'd like to do is take a few minutes. I want to see what questions we've received. So thanks for attending, and hold on, and I will be back in a minute. All right, it looks like we have a few questions. I'm going to go through some of the questions we'd already received first, and then I'll go to the questions that Jennifer's put together from you all tonight. So let me do that first. So first, we get a question about chlorination all the time, a lot, and we recommend that you should only chlorinate your well when you have a problem. So if you've got bacteria, then you should chlorinate your well, or shock chlorinate your well if you know you have an issue. Then test it again. And once the samples come back clean, there's no reason to chlorinate again. If you're concerned or you have an issue, the best thing to do is to just sample, fairly regularly to make sure that there's no issue. I think the question we received through the website was that I have a deep well, and I'm only 10 feet from my septic tank. So I've been chlorinating every 3 months. Well, the problem with chlorinating so often, if you don't need to, is that chlorine will eventually, for one, it can oxidize certain metals like lead or arsenic, and it depends on your area. They have to be in the ground and naturally occurring for that to happen, but they can. So that's one problem. And another is, if you have a deep well, you probably have a submersible pump, and you have, so there's issues with the pump apparatus, especially if you have a pitless. Some of those seals and the rubber gaskets and those things, all that chlorine can eventually wear those out. So you should only chlorinate when you need to. And if you do have a problem where you chlorinate and you come back and the samples aren't clean, they still have bacteria, then you need to do something else, because that means there's a connection. And especially if you have a deep well that's, a steel or PVC casing that goes down fairly deep, there still shouldn't, having the septic tank nearby shouldn't be an issue. It's really when the well's shallow or your water is coming from a shallow source that the septic is really a problem. So, if you want to follow up with us with an email on, some more specifics about how deep your well actually is and some of those things, there's got to be a pathway into your well if you keep having E. coli problems. And if you're just doing it because your well is close to your septic tank, you might be doing it for no reason. It's worth making sure, and the best way to do that is sampling. So we were asked how to determine if E. coli bacteria is coming from their septic. So they've had a positive test for E. coli in their well, and there's really no easy way. Now, at the U of I here, we've done some research working with a department on campus where they've actually been able to identify the source of the bacteria based on using DNA testing. So the idea behind this project was to determine if it was from horses or cattle or, human or whatever, and you can do that, but it's not really available to the public, and it's also really expensive. I talked to a septic professional today, and they typically, if they think there's really an issue, they run dye tests where they put dye in your septic tank, a lot of dye, and then run your, your outside spigot and the water in your sink, and you just use a lot of water for a while and determine if the dye actually makes it through. And if it does, then you obviously have an issue. And then a septic professional could give you advice on what to do next. But one thing to do for sure is look around, determine what other things might be there. Is there livestock nearby? Is there, any other possibility of, what might be causing this issue? It could be a broken line from your house to your septic tank, or there's other possibilities. And the more things you can eliminate, then it makes it more likely that it's, it would be the septic or whatever. So understand your situation and see what other, are you near farming operations, livestock operations, and those sorts of things would be something else to consider. A couple other questions we got today, and I did not have a chance to put in here with a formal answer. The best way to prevent a well from freezing, well, typically your well doesn't freeze. It's in the ground, even unless you're up in a permafrost area, very far north, your well doesn't freeze. It's usually the line between your well and the house, or if, the way where I grew up, we had a shallow dug well, and our pump set on top of the well in a small building, and we used, electric strips around all the pipes to keep them from freezing in the winter. In Illinois, we had, winters that were, we had below zero and that sort of thing. And when our pipes would freeze or when our power went off. So I need more information. If you're up in Alaska, that's one issue. But if you're in the greater 48 and you're having issues, it's probably not the well itself that's freezing. Groundwater is pretty constant temperature. And the ground doesn't, even the frost line is less than 3 feet. So in most places, even northern climates. So in that case, if you would give us some more information or give me a call, we can try to help you define your problem a little better. And how to determine where to put a well on a parcel of land. Hopefully this webinar helped with that. You want to be away from other things that might contaminate your well. It also matters, sometimes you don't have a choice. So many homes are on a second terrace or on an upland where there is no aquifer, but the back part of your property is down the bottoms along a small stream or creek. That's where the sand is, and that's where you can get water. So sometimes you don't have a choice. Your well driller would probably tell you where his best bet is based on what he knows about the area. And but if you do have a choice, and you're over a large aquifer that no matter where you drill you're going to hit it, then you want to put it in a high location that's away from any obstructions and upgrade it from any potential sources. And I guess that's the best answer I have. So that's that. Let me pull up these other questions. So here's the rest of the questions that we've got tonight. So it says, is a dug well also called a pit well? No, a pit well, at least in my experience, means that the well's down in a pit. So as I explained earlier, in the old days, what everyone did is they dug a pit that was 4 foot deep or more, and that's where they installed the well. That way they could keep it from freezing in the winter. And so if you're in a warm climate and they talk about pit wells, then that's a term I'm not familiar with. But if you tell me where you're at, and that is the case, I can try to talk to a well driller and find out. A dug well is just a large diameter well. That means it's usually 3 foot diameter or larger. And it's meant to collect shallow seepage from infiltration, usually rainfall. So, in the well log example, this had the term slot near the diameter of the well. What does that term mean? So depending, when you drill into a sand and gravel aquifer, you might run into gravel, you might run into large sand grains, or it might be very fine sand. And you want to not pump that sand in your well. It'll ruin your pump. It'll get in, there's people who they don't have a choice because the sand's so fine it comes through any slot size that you have. That slot is the diameter of the opening between the steel rows of screen. And so that screen I showed on the diagram, there's space between those stainless steel woven screen lines, and that's the slot size. So it's based on the sand particle size, and the idea is you have the slot size small enough that the sand can't get through, but the water can. And like I said, in some cases, there's people who have to have 2 pressure tanks, and the first one is mainly to settle out sand that comes up through their well. And you don't have a choice because the sand's so fine, it's so small, that there's no way to pump water and not pump some sand. Or they use a filter and they're changing it, once a week or less. So, yeah, that's what slot size means, or slot means. What would be ideal depth for a well, and what depth would you just too deep to try to get water from? It really depends on the geology of where you're at. I know in some parts of Illinois where there's sand and gravel and glaciated terrain, you may only have to go, there's aquifers that are near the surface. There's also, in the Chicago region, they have sandstone aquifers that are at 2,000 feet that are still fresh water. But in southern Illinois, there is no fresh water. It's unglaciated, and the bedrock is at the surface. When you drill down and hit a water source, whether that be limestone or dolomite or whatever, it's salt water, and that's left over from millions of years ago when this was an ocean. And so that water isn't potable or for use. So in southern Illinois, they use lakes and streams and for their water source. And so really there is no ideal depth. Like I said before, if you have a choice, deeper is better. For instance, if you were going to drill into a 100-foot sand aquifer that's at the surface, I personally, even though it would cost more, would put the well down at 100 feet at the very bottom of the aquifer, because that way any water from the surface has to infiltrate through 100 feet of sand to get to the screen where I'm going to be pulling my water from, so you're less likely to have higher nitrates or any other kind of contaminant that might happen at the surface. Whereas you might have in that aquifer, the water level may only be 10 feet, so you could put a well in that's only 20 feet deep and hit and have a water source, but then you may have more contamination issues. So it really depends. You need to talk to somebody locally, like your state geological survey or your well driller. And what's too deep? A lot of times, one thing we do know, especially for bedrock aquifers, is like if you remember on that well log, it showed the one that had the fractured limestone, it showed like 6 feet of broken limestone and then 89 feet of limestone. Well, at the top of that rock, because it's at the surface of where it's unconsolidated glacial materials, and then the bedrock below, it's a lot more broken and cracked and fractured, and there's much more water in all those fractures. And a lot of times, especially in like a limestone, the deeper you go, the less fractures and the smaller the fractures are. And so there becomes a point where if you haven't hit any fractures and don't have any water, you're not going to find much. But again, that's something that, you really just have to rely most of the time on a local driller, because they're the ones who've drilled in that area and understand what the options are. Now, the last question here, my home has an aeration system, chlorine tabs, fluid runs out the back. I don't understand the question, to be honest. So if you're putting regular chlorine tabs in your well because of that's what's required, yeah, I'm not sure what it means by fluid running out the back. If you want to give us a call or send us an email, we can follow up and try to answer your question, and I apologize, but I'm not that familiar with the treatment side of things, and we have a lab here, and I rely on those guys, and partly because this is an evening event, they're not here with me tonight, so probably my best bet is to get back to you if you're willing to send us some more information. Okay, I believe that's all we have for tonight. I appreciate those of you that showed up and participated, and if you have any further questions, you know how to get a hold of us. Jennifer's typing one more thing. So it's like a septic system. Yeah, I'm not familiar, to be honest. So I need to talk to you about that. So, but we will help you. That's the bottom line. So, all right. Thanks again for participating. And with that, everyone have a good evening, and I'm going to log off. All right, take care.